So it's kind of funny because people, I see this a lot when people start developing in any game engine, in Corona SDK or the Torque game engine, is they kind of like focus in on the detection and completely ignore the response. And it's like this real weird thing for them. They don't understand it. And the reason I find this funny is because in the real world, all we see is the response. Real physical objects only have response. There's no such thing as detection, right? If you think about it. Detection is merely a logical thing that we use in our code to make decisions. So anyways, before we go down this alley here, just remember that the important function here is either self-destruct or delayed self-destruct, which we're going to use later when the collision occurs.
Can I add another note?
Sure.
So if you're having this problem of collisions and physics fighting, you should really consider using only physics for movement and not transitions. Mm-hmm. And I have an example of that's happening. So you press some point on the screen, and your physics character is moving towards that part, like with physics it could be done. And Ed, maybe you can open a link that I will be posting to the chat. So if you could scroll down, there's enter frame listener. Here it is. So this if statement with the movement is calculating to which direction the character is moving and applying linear velocity towards the direction with regard to speed, and speed has also acceleration to it.
So this is interesting.
This is an example of doing it.
Sorry.
Mm-hmm. So yeah, that's it.
All right. So there was a question I saw in the forums this week where somebody was kind of puzzling over this, and I just wanted to say that I find this interesting. I've also done something like this before too, and at first when I did it, I felt like it was kind of wrong, although it is not wrong. And the wrongness of it, the sense I had was, is if I'm resetting the velocity all the time, that seems sort of excessive, because what you're doing here is basically assuming that it's moving, you're calculating a new velocity vector every frame and resetting those components of the engine, the physics engine, every frame for that body. And part of my brain said, this seems wrong. But in reality, there's a huge gap between the time when you set the velocity and the next time it's going to be used by the physics engine to make a decision. So if you were doing this and it wasn't, what I'm trying to say here is, if you were changing the velocity at some random point, then it would be wrong. But we're not changing it at a random point. This is a handoff point. Enter frame is a handoff point. It's where the engine has said, where the SDK has said, okay, I'm done with the physics stuff. I did that. I did all the rendering. I'm going to hand it off to your user code to do something. You can do anything you want. And then we choose to change some parameters, be they position, or in this case, the velocity. And then after we give up ownership of the execution, and our code is finished executing, we hand it off back to the SDK, and then it is completely correct, and it completely works, that the physics engine then gets its turn again, and it says, oh, velocity changed? Got to do something about that. Apply the calculations, make the correct movement updates, next frame, do it again. So if somebody is struggling with that sort of like inner debate of whether or not it is okay to set the linear velocity every frame, it is in fact okay to change that every frame, and you're not going to have any negative side effects. So at least I've never had any. Sorry, you can't see me there. I'm taking a sip of water. Otherwise, I get crackly over here. So let's go into the part where we are shooting our arrows. And let me find it for us. So the part we're going to elaborate on today is just the one bit where we fire the arrow. And this is sort of what we were looking at last week. But we're not going to talk about the movement. We're going to talk about the collision. So when we fire our arrows, we call a function called fire arrow on the player object, and this is in the player maker function, which is under game scripts playermaker.lua. And in here, we do some calculations. We check to see if we have too many arrows in flight. We get the current time. We make sure that we're not firing our arrows too rapidly. So this piece of code is saying basically, if you've got an arrow in flight and you just fired an arrow a certain time ago, if that was too recent, don't allow them to fire because they're clicking the mouse button. Just ignore that click, do nothing. But assuming we get past that, we call our arrow maker, which is in, I don't have it up here, but it's the sprite code for making the arrow. And it basically creates an arrow, puts it in the content layer at the current position of the player's X and Y. And we use the player's angle, not the rotation, but the internally tracked angle that they're supposedly facing. And we pass that into this maker, and it chooses the right animation to select and play. And then we add a body. We did this last week. We make that body dynamic. We give it a small radius. Let me just, oh, I already turned that code off, but we saw earlier a little circle around the center of the body. Again, this is my cheater's code. I should pause here for a moment. Mike over at Crave Creative pointed out something to me last week. Another way to approach this body is, if you wanted to, you could create bodies with, you could create physics bodies that had multiple sub-bodies. Now, this is not something I do very frequently, but if you absolutely needed to, you could create a sub-body for the arrowhead, or a sub-body for the shaft, or whatever you needed to do to get a more exact collision profile that would be more accurate in your game. But as I pointed out last week, we don't worry too much about accuracy. I have a lot of slip in the accuracy here. The bodies of the players are fairly large. In fact, let me just turn it on so you can see what I'm saying. Let's go back to hybrid mode here. And I'll reload this. It makes more sense to talk to it as it is happening. So as we can see here, there's a physics body around our player that's very large, but it's not quite as tall as the player, but it's fat, fatter than our player. Then we've got a physics body around the sprite of these enemies. It's also kind of fat, not quite as big as them, but big enough, something that we can aim at. And then let me get this a little better. So here we can see that the arrow itself has a really big body compared to the graphic, but if we were to follow this along, this is almost certainly going to be a collision because it's going to graze that circle. It's going to graze that bounding circle, and that's close enough. So in our game, let's just play it out a little bit. If I shoot off to the side, I'm going to be so distracted by needing to shoot all these guys before they come and kill me that a slight grazing that kills is good enough. And you know what? If you're playing this and you feel like it's not quite right, you can always just go in here and change the radius to make it bigger. For example, let's make it 4 times as large. Twice the radius is 4 times the diameter.
Is there a point, Ed, where it can be too small?
Yeah, so let's make it really small. Let's make it 1. Itsy bitsy. It's a little itty bitty tiny circle. You know, and I'm still, it's not so it's too small that I'm missing. But now a grazing shot will go right by and not hit. So as you can see there, that arrow just grazed this player or this enemy, but totally missed him. And the reason is because the body, it's a little bit hard to see with a reticle in a way, but the body is actually below the graphic that we're visually seeing. We're thinking, that's the arrow. No. The arrow is, the body itself is a little bit below that in this case. So it grazed it, no impact, missed.